So for question number 3 on test 1 part 2, we're asked to find the magnitude of D and what it's closest to. So vector D is given by B minus C. So in order to find the magnitude of the vector D, we need to find the magnitude of the vector B and the magnitude of the vector C and then subtract them. So up here, I already have written the values of B in the I direction, or X, the X values of B, and the X values of C. And here I have written the J values of B and C, or the Y values of B and C. As you can see, the X values of B and C use cosine, and the Y values of B and C use sine. Even though the numbers are the same, the values are going to be different because we're using cosine and then sine. So now what we need to do is just put all of the values that we just found of vector B and vector C together. So here we have the values of vector B in the I direction and the J direction. And here we have the values of vector C in the I direction and in the J direction. So now all we have to do is solve this in the calculator and it will lead us towards the right answer. So once we simplify the value that we got before, we'll end up with the magnitude of D and square root of 6.5 squared plus 1.46 squared. And we're doing the square root and squared because we're finding the magnitude. So we have to square the values and then square root them. So once you simplify these values, you take the square root of you square 6.5, you square 1.46, and then you take the square root of the sum of those two. You will get the answer 6.66. So that means that the answer was C on the test 1 part 2.